So I'm Ricardo Rius. I work for Parity Technologies. I have been involved, I started in the blockchain ecosystem in Ethereum, just learning smart contracts, and now we are pushing forward the next generation technology. So we are gonna be talking about Substrate, Rust, WebAssembly, blockchain upgrades, and interchain communication using Polkadot. So over the last years, we have seen an explosion of different type of blockchains, but there's not really one that can handle everything. There's no one size that fits all. So we know that the future needs to be multi-chain. In this case, we can build some blockchain for speed, some for privacy, maybe also one for its own identity, so you can handle all the country identities on one blockchain. Also, we have seen that in many cases, enterprise needs aren't met. Public blockchains don't meet really permissioning and confidentiality. Like also when they build probably with other technologies, all these blockchains stay isolated and they cannot intercommunicate between them, so you still have some silos in there. So if one company wants to build its own blockchain from scratch, you really need to think on many, many different things. So for examples, you need to develop some peer discovery, you need to write some protection against DOS attacks, civil attacks. You also need, or should be very useful if you write some live clients, because you don't want to keep in your laptop 10 billion blocks or in your cell phone, so you only want to access the information when it's needed. You need to build your own consensus, and also all the logic that needs to be imported needs to be deterministic. So thinking on all of this, that's why Substrate is here. So Substrate, it's an open source, modular and extensible framework for building blockchains. It really from the bottom to the top, it gives you the database layer, networking layer. It also provides transaction queue, consensus engine, and support libraries and palettes. But you can also build your own custom palette. It doesn't need to be one of the palettes that we provide. You can build your own logic and also plug it to your own Substrate chain. So here we have a structure of how Substrate works. First, we have libp2p as the networking layer. Then we have the consensus layer. We have WebAssembly, and then there's the runtime. So I'll explain a little bit more later about the runtime, but here I just want to say, like, the runtime, it's built, for example, also in WASM and in native code. So this will be something quite important in the future. So for example, what is a runtime? So Substrate uses the term runtime to describe the core block execution logic of our blockchain. So this means that it's the state transition function. So in order to build your own runtime, we have palettes and libraries. In this case, we have like balance, consensus, contracts, indices. So the thing here is you select what kind of palettes, which are contain logic, and then you just plug in as if it's a Lego and you build your own blockchain. So there's also a need to do some upgrades in the future, because you like as any software, you always need to fix important security vulnerabilities, change some rules, add functionalities, repair probably the chain state. So in order to do this, actually there's like a common way of doing it, and it's through hard forks. So the problem with hard forks is that you need to tell everyone on the chain, everyone connected, all the nodes, to update at the same time, or at least have updated their nodes just to be able to get the new update and sync into the new chain. Otherwise, the chain splits and then you lose a lot of security doing that. Imagine what could happen if you have an, I don't know, IoT chain, and then some devices don't update correctly and they go to one chain and the others go to the other chain. So this will be really a big mess if you are building some IoT, because it's super difficult just to get to every device and then just update the logic in the... So in our case, we can do on-chain upgrades. So these upgrades, that's why I was mentioning WASM, WebAssembly. So these updates will go through WebAssembly. There are different ways how you can set up these upgrades. So for example, in a proof of authority chain, you can use the pseudo module, pseudo palette in this case, and there's also like democracy palette, and you can add some consoles. And depending on the type of governance that you want to put in your chain, you can select how to do these upgrades. Also, these upgrades are optional. You can just deploy and probably never upgrade, but I think it's probably not what you will be looking for. So now getting back just to the runtime, we have the WASM part and the native part. So the way how we prevent hard forks in Substrate, it's using just WASM. So in this case, the binary will select if the version of the WASM blob it's newer than the native code, and it will execute the WASM blob. So the WASM blob here, it always lives in the chain, in a really specific part of the chain. So everyone that is syncing the chain will always have access to that WASM blob. So by doing this, you will always execute the latest rules. So if the latest rules came because it was using democracy or it was a proof of authority chain, it will follow the WASM rules if they are newer than the native ones. Otherwise, you will execute always native because native is faster. So if both have the same rules, you just go for native. So now let's just show a demo on how to do these upgrades. Okay. So here I'm getting to substrate.dev, which is our main hub for developers. And in this case, we have like just tutorials. I'm gonna show you how to create a really fast decentralized application. I already have I just did these steps that it's cloning some repos from the dev hub. Then this example will be just super simple. So we will have one file, we will hash the file, and then just upload the hash of the file to the chain. We can also revoke then this hash, just delete the hash from the chain. But our first iteration will be just to create the claim. So in this case, we have different palettes in here. For example, we have the balance. We have grandpa for finalization. This one, it's the one that really finalizes every block. We are gonna use pseudo because it's gonna be a permission blockchain. and timestamp and system libraries. So the way how our project is gonna be structured, it's just following the Rust logic, where we have the cargo tom files, then source, lib, and yeah, we will just edit a template here. In this case, for example, something that we always need to declare in every palette, we need to declare events, we need to declare the storage, and then we declare the module. So in the events, it's like as any other like blockchain, you want to just tell the outside world some things that are happening inside, and you just emit some events that can be read from JavaScript or any other RPC. Then declare storage. We will declare like all the storage variables that we need in here, and declare module. Here we put all the functions. So now after this, let's just go to the code. Okay, so the node template, it's really super basic here. It doesn't include, no, here's the node template, that's just the front end. Okay, so the node template includes just one really simple palette, which is the template. It's the template palette. It's this lib palette, the template. Okay, so we are gonna modify this just to add some functions in here. So I'm gonna do this super fast. I'm just gonna copy here, and then so we need to import some libraries and also some macros, like declare storage, declare events are some macros from Substrate. And then here we need to declare also our own storage variable, which in the default is just U32. It's not really something very interesting. So we are gonna put something else in there, which is this proofs. It's a mapping, which will be mapping from accounts to a block number. This should go up here. Okay. Then we are gonna add just the, okay, that can stay there. We are gonna add just some functions in here. And it's kind of difficult just with one hand. Okay, so just to show then the upgrade mechanism, what I'm gonna do here is I'm gonna comment this one and just add one that will be the create a new claim. So creating a new claim, and then we also need to declare some events. So here are the two events that we need to add. And basically that's everything that we need here. So We need to compile this, which should not take more than like 2-3 minutes. Oh. Okay. So in this case, what we will see right now, it's just our chain with a new function in here. And then we will add a new function and do the upgrade while the chain is running. So right now we just like created our chain without anything, like just basic one. We are starting from 0, and then just we want to show how to do the chain upgrade and add new functions in there. Okay. And here we also need, there's a interface that's called polkadot.js.org/apps. Okay, connection is kind of messy here. Okay. So, for example, here we are right now just as default connected to Kusama, which Kusama is a pre-launch of the Polkadot chain. It's not really like the main net, it's just proving how everything works. And in this case, for example, there's democracy. Kusama is now decentralized. So there are some referendums in here, but we are gonna use the same interface here to connect to our own blockchain. But let's see, okay, so finally, this just got there. Let's execute our chain. Okay, and let's connect to this chain. Okay, so now we are connected to our chain. It's just 2 blocks right now, 3, and it will keep going there. So what I want to show here is that the template that we just did, it has only 2 functions, which is the create claim and the one that came by default here. So claim, it's just useful because we will just upload a file in here, and okay, let's just load the local. Okay, so here's our node template. In this template, we can just choose a file. Our node is running now just in the background. We are going to upload a file, and it just, we can now create a claim. Okay, so now it's claimed, but we cannot revert the claim because there's no function to revert the claim. So in this case, we are gonna add now the new function, which will be revert claim, and then we will just upgrade the chain without stopping it. It will be a on-chain upgrade. Okay, so we have this. We are gonna just tell that the WASM version it's gonna be newer than the native version here, and then in the node template we can okay. Okay, again, it's gonna take like just 2 minutes, and we will have a new function in there. Just after this function, we will now be able to revoke our previous claim, because this was something that we didn't account it at the beginning. So now we know that we want to revert claims. So let's just wait, and then I'll show you how we upload the new WASM blob to the chain, and the node will automatically execute this new blob. So it will have these new rules. Okay. Just waiting. Standard compilation times, just live demo. So yeah, it takes a few minutes. But still, our chain is working there, and we will not stop, just to prove that we are gonna do the live update. Okay, yeah, 2 minutes. I thought it was longer, but yeah, nice. Okay, so now let's do this upgrade. So we are gonna go to the sudo palette, create a new proposal, which is to set new code. So this new code will be the WASM. So here we have, so this is just a 200 kilobytes file that will have all the logic that we need, and then we just upload the file. Okay, so it got in. The UI is telling us that there's a version 2. We just need to reload the UI. We haven't stopped the chain, as you will see here. Chain is still there, 60 blocks. And here we'll see that in our template we have a new function, which is revoke claim. So in this case, we just choose the same file, and it says that it's already claimed, but we now can revoke the claim. So nice. That just went through an upchain and chain upgrade without stopping anything in there. So that was super easy. And now, for example, this is just a little bit more, it's a little bit more complex tab application. Like what we just created here was a tab with a Parity codec talking to a Substrate node through the RPC and through the blockchain. But there are also some other components like the opt-chain worker, Parity secret store, which it's being just developed for Substrate, and opt-chain workers, it's something super interesting because it gives us like just a new option to add oracles and to interact with other type of systems. So the basic idea or the main idea of opt-chain workers is to be able to create some HTTP calls or just server calls to other places, SQL databases. It also can generate, because it's done off-chain, it can also generate random seed generation. So this is not like just the tricky things that we are doing now, like in Ethereum, just to create some random things in there, which are not completely secure if you do in a smart contract, because it can be predicted. So you need to do this off-chain. In this case, we use off-chain workers for doing that kind of stuff. And also, we have the trusted execution environments, which help you just to maintain more confidentiality in your information. So up to here, we have just showed that we have one more chain in there. So everything is still fragmented in some way, no? So in order to fix this, we have Polkadot. So Polkadot, it's a network interface. This will just ensure the connection between different blockchains. It doesn't need to be built on using Substrate, but if you use Substrate, basically it will be just a plugin. It will be super easy just to put it. So how did Substrate really started? It was more like we started building Polkadot, but then we realized that many patterns are the same for building just blockchains, like the network layer, consensus, all that stuff. So instead of keeping it in one main repo, we decided just to split it and create a framework that anyone can use. And for example, this is just some detailed version of how Polkadot will look like in a small scale. So we have parachains in this case. We have bridges to other blockchains, like could be to Ethereum, could be to Bitcoin. We also have other concepts of parathreads, which just are like parachains, but dividing through time. They need another mechanism just to put a block in there. But what really stays in the relay chain, it's that it only keeps proof of validity, it keeps proof of post and misbehavior reports. So you don't store a lot of data in the relay chain because that's important. You don't want the chain to become super big and then just like you cannot store it anywhere. And then you offload like all the balance transfers, governance, and staking. You put it always on the parachains. So this is how Polkadot will look like in hopefully near future. So for example, some things like are super useful are if you want to create in smart cities, like as I said, IoT devices, it's easy to create because like Polkadot and Substrate was designed since the beginning for light clients. So all the implementation, it's super light client friendly. You can design it for having your nodes in cell phones, in I don't know, maybe also Raspberry Pis. It's something that we have already done. You can run in Raspberry Pis your Substrate nodes. You can basically just like as I said, another benefit is the on-chain upgrade, so your nodes will stay on the same chain. Other thing could be, for example, a good example in supply chain, it's more than just the commercial ones that we always know. It's like, how do you really track the provenance of some diamonds? Like, the way to do it for diamonds, it's like a diamond, it's super difficult unless you smash the diamond or anything just to change the shape. So you scan in 3D the diamond and then just create a fingerprint of that diamond, and then you just put that data on the blockchain and you start tracking the diamond. So when the diamond gets to any place, you scan the diamond again with 3D, and then you know which diamond it's, and you can track perfectly all the where it comes from and everything that was related to that diamond on every step. And yeah, I think that's all from my side. So, any questions?
Thank you, Ricardo. Any questions? Guess it's not that of a technical audience. Maybe a little bit hard to grasp for most of you. One in the back.
So the example that you were showing with WebAssembly, just for me to better understand from kind of coming from Ethereum world, it's more of an example of a smart contract, but only upgradable one. So the logic was built into the blockchain in the very beginning, right? And later on, you just made the necessary adjustments, whatever they were, kind of. In that particular case, it was a revoking of claim, and then you kind of just upgraded the smart contract on that particular chain. Is that what I understood is correct?
So in this case, it's more like you're updating. Let's say if you compare with Ethereum, you're updating really the Ethereum virtual machine. You're changing the rules of the virtual machine. You're not just changing the rules of one smart contract. So by doing it this way, you can really like add new rules to the virtual machine without asking everyone to update the nodes at the same time. So it's not the same as smart contract because we also have the pallets contract, which it's just something that it also involves its own WASM execution environment. So you build on Rust or also we are developing for assembly script. And then you can deploy smart contracts to that palette that belongs to you, that it's in your chain. But right now, it's more like just upgrading all the runtime chain, which the runtime, it's really like the rules, the execution environment in your chain.
Okay, thanks.
Are there any other questions? Yes.
Hi, thank you for your talk. Do you also provide some sort of guideline? Because in this case, the runners of the blockchain network are able to upgrade the logic from one moment to another, and so this affects the users because users, when they read the blockchain or when they kind of like assume that there's some logic there, and if the other moment it changes, do you also provide some way of guidelines like how to cope with changes, how to cope with these updates?
So this is completely free to the parachain developer because, I mean, as I said, you can choose to put some governance in there, some democracy like Kusama that it's super open now, and you can put like motions, and then you can like ask people to vote for everything, and so everyone just go to a portal and they know what's getting into the chain, what updates. Or if it's a proof of authority chain, somehow you are probably also in control of the final user in some way, like you just have some devices that need to get this update. So you do the update through the runtime without forking or forcing them to fork and then upgrade and all that stuff. So this is completely open to you. You can select perfectly what kind of rules, what kind of guidelines. That's flexible.
Okay. Thank you.
Any further? Oh.
Does this methodology introduce any security vulnerabilities?
No, it doesn't, because when you create the WASM blob, which is the one that goes to the chain, you also generate the hash. So you can validate that the exact code that you have in your machine, it's the one that it's getting in. So like there's, in the same way as every open source code, you can just analyze the code that it's getting there and then just generate the same output. And if you have the same output, then you vote to accept the update. Otherwise, you vote for not accepting the update.
So there's no mechanism to introduce a worm or virus into the code?
No, there should not be, like if it's been audited and it's open source. I mean, in any open source project, you can have some, but that's up to the community just to really audit the code and get into that. But no, there's nothing extra that gets because of these kind of upgrades or something special here.
I have a question which is more like a question about the Rust part. The pellets you showed, can these also be scaffolded with cargo or something like that?
Say again, please.
Could the pellets you showed, these pellets,
Yeah.
which basically are small modules, parts,
Yeah.
can they also be scaffolds?
Not really. You need to follow some specific rules, but you can create your own custom palette. So, yeah, I mean, you can put many different kind of logic there. It should be able to compile to WASM. If it doesn't compile to WASM WebAssembly, then probably you should not use that kind of code in there.
Yeah, I have another one. Is there something why you use Substrate instead of like the other platforms? Why would you use Substrate instead of, like, let's say IOTA, Hyperledger Fabric, or and maybe in basic words, because some of the audience are not that technical. So can you elaborate on that, please?
Okay, so first of all, it's like just how you interoperate with other blockchains, like through Polkadot. That's a really big benefit. We know that we will need to be able to have this intercommunication. And now for building with Substrate, it provides you like a super extensible, customizable environment. So you can add your own logic in there or use community's logic. Like in the future, you can imagine some outdated palettes that another company, another startup just developed, and you want to take it and just extend your blockchain functionalities by doing that. So basically, it's the powerful. It's the really Substrate gives you a lot of power just to build something from scratch, and yeah, that's one of the main things. Like also the thing about using WebAssembly, it's another super really useful thing, because imagine that you can create this. So WebAssembly can be executed on your browser because it's compatible in some way with JavaScript and all the stuff. So imagine that you can also like use a full blockchain, a light client in your browser without using the same logic that you are using in your phone or in any other. So this really opens the possibilities to access many more. It really just empowers you to create more and more things around the tech.
Okay, thank you. And if they want to learn more about this, what is the best place to go to? I guess the wiki, or is it some other place?
Yeah, so for Substrate, it's the dev hub, which is substrate.dev. For Polkadot, there you have the wiki. There's a lot of information about Polkadot and also the newsletter.
Okay, thank you, Ricardo. Give him a warm applause, please.
Thank you.